So, Vanakkam, we will start our discussion on the instrumentation, seismic instrumentation in India. So, we discussed that we have been very poor instrumentation even until 1960. After 1960, we have been engaged in the several other institutes to support seismic station networking in the India. There are several institutes, okay, the government institute, state level institute, and the government dam managing agencies and all step in and try to build a local seismic network or regional network. We have also seen that among the many of the regional network, very few people add a broadband seismometer. So, most of them basically add a vertical component, single size component seismometers, which may not be so much useful for engineering application. And we also discussed that there was a lack of proper seismic data, okay, in the country because of these are the regions. So, this has been visualized and then understand by the Ministry of Earth Science. So, then they start building a very good seismic network in the country after 2000. After 2001 Bhuj earthquake, it triggered alarm to the many of the people. Tried to first thing to understand the earthquake is basically measuring the earthquake and understanding where it occurs, how the waves are propagating, as we have seen in the preparedness for the earthquake risk reduction is the understanding of the earthquake. So, if you look at as on now, okay, so you can see the India map where there was a seismic stations marked throughout the country. So, you can see basically, so how the seismic stations are. So, you can see here, okay, so this is basically Delhi, okay, so Delhi they maintain their own Delhi regional seismic network. So, you can see the Delhi region and you can see how many number of earthquakes are reported. So, this may be the reason that whenever there is even a small earthquakes are occurring, you can get immediately recorded and reported because they have the considerably more number of seismic station than any other big cities in India, okay, Delhi. So, the another network what they maintain is a regional network is actually northeast. You can see here northeast. So, even though the northeast has 7 states, but each state at least they have the 2-3 seismometer. So, when compared to this smaller area, the number of station fixed years are more when compared to other part of the India. Okay, this is also some kind of regional dense network you can take, but since it has a large variation of the topography as well as the geological formation, okay, so this number of station in the region itself may not be sufficient according to the international station requirement. So, if you look at the India, okay, you can see the number of station. So, you can if you zoom into the closer to southern India, you can see the India there was actually very few stations are located in the southern part of the India. So, the lack of number of station basically lead to less number of micro earthquake recordings. Basically, there may be earthquake, since you do not have the instrumentation there, it may not be recorded. So, since there is no record, so you should not feel that there is no seismic activity in that region. So, until you have the very good seismic network, then if there is no earthquake recorded for the past 50 years, 100 years, you cannot classify particular region as a low seismicity without having the instrumentation. Okay, there are many places where the vibrations are felt. Okay, so it has been reported in the newspaper or local TV channels, but there is no record, seismic record near to that. So, many times faraway stations which may not be able to pick up. For example, if you are a seismic station, regional network stations or the earthquake short period sensors are available at a distance, okay, more than the twice the depth of earthquake, it may not record those earthquakes. So, that is the limitation. So, with that limitation you can see that the number of stations in this map. So, there are still some analog stations are being monitored in the country. You can see where and all analog station is there. For example, this one and this one, these are all the analog station. So then the digital broadband station. So the blue ones are the digital broadband station. You can see that these stations are relatively central and the northern part relatively distributed well. So the real time monitoring, seismic monitoring network, which basically communicate with the satellite and try to transform data to the this one. So this is the Delhi network where the purple triangle, and this is the northeast network where this one. So this is a seismic network in the station, where now even the IMD working towards to improve these stations. So this is as on December 2012. Okay, seismic station December. So now there are some stations are upgraded and some stations are basically isolated. So as on this network, you can see what earthquake you can record on what regions. For example, if you look at this portion, so this region also part of India, where you can get any earthquake which is more than 3.5 magnitude. This is basically, these are all maybe the acceleration sensors. So then this region, anything again more than 3 you can felt, 3.5 this region, 3.5, 2.5, so 2 and 2 and overall 3.5. So most of the seismic stations whatever is there, the lowest magnitude what we can record was around 2.5 and above. So which actually makes basically make a questions, if there is a earthquake occurring less than 2, it may not be picked up by your seismic station, and even human may not feel this earthquake. Those kind of seismic activity, if it is not noticed, it is very difficult to understand these regions are seismically active or inactive because of the lack of sensitive earthquake records. So this is the state of art instrumentation in India. So you can see the same kind of data in the bigger scale. So where the existing IMD equipments and then the other, and IMD planned a few more stations. You can see basically they are planning to upgrade, so fill the gap in southern part more and also add many stations in the this one northern part. So all this seismic observatory, how it works presently, because the government try to upgrade and try to modernize this seismic station continuously with IMD leadership. So basically how the stations are working, so all these stations now they are making completely digital. Okay. So what it does basically, it records earthquake, okay, then send to the computer in the particular place. That computer sends signal to the nearby satellite station. From the satellite station it is sent to the satellite, and from the satellite it again comes to the other computers and network in the system. Okay. So based on this magnitude, level of magnitude and PGA, it also sends warning to the people who are registered their names for knowing the earthquake. So that means if there was a big earthquake, you will get to know from the your SMS or email or phone call, this is the earthquake occurred on this region, which is very important particularly to disaster evacuation and planning, and also to stop some of the travel, all those things. For example, there was a big earthquake in the Delhi, then soon after the earthquake people know that there was a earthquake occurred. So immediately you can reroute the flight which is going to land on the Delhi airport, assuming that there is a situation will be bad and how the airport might be damaged, you can know the size of the earthquake. Then you visualize that how the infrastructure in that particular place, it is possible to land or not. So accordingly you should reschedule. So those are all the preventive measures, and reduction of the hazard can be taken up effectively when you have this kind of station. Okay, so communication, and then the basically sitting with the computer and then trying to disseminate your knowledge in the larger group of people. Okay. So that was the arrangements, now it is available. So this is how it works basically. You can see, so the seismic station will record and then transport to the control system, where is this Noida there is a hub, then it is transferred to the satellite, from satellite it is going to the all the around people. So, all of them is basically controlled by the satellite based system, where even your local networks are affected, it can be effectively work. Okay. So, other than your communication, but the data other things may not be lost. So, there are some of the permanent satellite station in the country where you can get direct communication with the satellite and transfer your data and receive your data. So, this some of the station actually, even close to Bangalore there is one station, and close to Delhi there is a one such station, where I was actually acting as a consultant to design up getting a dynamic properties to design this satellite station. Okay. So, the part of Trinetra project. So, that time I could have, I have seen all these things as a so, right now, so you can get the IMD website, where you can see where the earthquakes are occurring, what is the magnitude, what is the depth, okay. So, what is the time period you will get SMS. Actually, SMS can be received level 1 by 8 minutes, level 2 by the 13 minutes. So, if you access the website, you can see like how the source and what are the station it is recorded. So, using the data you can try to estimate what is the location of the earthquake, like epicenter, depth of the earthquake, and then the focal mechanism. Okay, that also is get, and you will also get the shake mapping, and then this earthquake how many stations are recorded also you will be coming to know. They have the software which is integrated with the national level as well as the international level kind of things, where the particular earthquake it can display the this one earthquakes. This is the Bay of Bengal earthquake 6 magnitude, where the soon after this like when it is occurred and what was this one, when it was alarm was issued, details are given here. So, the earthquake report is released by the IMD officially. So, the earthquakes are happen. So, this is a different network. So, that depends upon the network when they release, like RT, SMN network 2 to 5 minutes, level 1 release, IMD, MOES core official they release. So, the level 2 will IGS 5 to 15 minutes, level 2 release. So, then they will also update this one, it will release to state government, okay, as a news, media and public after the 15 minutes. So, the Northeast network Delhi earthquake report released by the SMS as well as the website facts and the IVRS depends upon the magnitude and the level of damage expected from this kind of earthquake. So, this is the typically the website where soon after earthquake you can see this is the earthquake. So, they also give the intensity scale, what is the felt and what was the level of intensity which is reported on this. We will discuss what is the intensity later stage. They also release a intensity map, which also we are going to discuss in the next class. So, the intensity map basically tell you how much damage is expected, okay, due to that earthquake, which is not reported, which is estimated. For this you need a intensity predictive models. Okay. So, that model one can use by knowing the magnitude and distance, that will prepare a intensity distribution map at particular earthquake. So, by knowing this we can show that wherever red, very dark red is there, so that place where you can expect more damage, wherever there is a light color you can expect a less damage. So, like this. So, in general most of the intensity equations so predict that the close to the epicenter location you will have the more damage when compared to the far away from the epicenter location. It can be noted here that this intensity predictive equation, right now India has only one intensity predictive equation developed for India, which we will discuss when we are talking about the hazard analysis and predictive equations required for the hazard analysis. Okay. So, this is how they release this map, is called intensity map or shake map. They release soon after the earthquake. So, to give a approximate estimation of how much area it is affected. Okay. So, how much the area affected, based on that you can guess how the severe earthquake. So, there is a response time, okay. So, of the each station to the how the data they will get and try to analyze and try to understand when where the earthquakes are occurring. For example, So in period to 1996, so we have most of them are analog observatory, as we have seen that the analog stations are write a earthquake waveform as a so in the smoked paper or paper using the pen or pencil marking, where the earthquake signals are basically written as a waveform. Okay, so this will be basically draw a waveform. So basically, so the when there is no earthquake, it will be moving like this. When there is a earthquake, so it draw like this. Okay, then like this is draw. So then it slowly reduce and go to 0. So then the analog basically they take this data and put it on the trace paper, try to measure a amplitude and then try to estimate what is the earthquake magnitude using this, and then that magnitude they report, which will roughly takes about a hour to report those kind of earthquake information. That is why in 19 period to 1996 you can see the period. So before 1996, okay, period to 1996 we can come to know only earthquake after a hour, 1 hour. By the time the earthquake may be felt by the wide people around the epicenter, and it may have caused whatever damage it has to cause. So there is no it does not help for any warning or anything. Okay, just to know earthquakes are recorded values we have, that is all. So in 1997 to 2006, so we are slightly improved. So when the digital system came, so where they try to get the information at within 30 minutes. Okay, half an hour they used to get. So they followed by, so it again so improved further when digital observation, VSAT and auto location, what we have seen in the satellite based communication and auto location, where we could able to get a earthquake information within 15 minutes during 2014. Okay. So then this has been now improved. So where as on now we can get 5 to 8 minutes about the earthquake magnitude, earthquake location precisely, earthquake depth, all those are possible now precisely within 5 to 8 because of the digital observatory, as well as it has been communicating with the satellite and storing the data and disseminating very fast those kind of information. So now the country also working towards, okay, going forward towards basically early warning system. Early warning system means, so as we have seen that this is the P wave, then followed by this is the S wave. So in between this time, okay, so is sufficient to stop some of the important facilities. So basically if you know this one, you could guess a magnitude, okay, then based on that, before this waves comes, you can shut down some of the facilities, particularly the underground metro, nuclear power stations, all those things, to prevent a disaster. Okay, so this is practiced in Japan, where they have the very dense seismic network. For example, this is the place where the seismic source is there. So then if you have the seismic instrument here, if based on the P wave, if you guess what is the magnitude going to come, if a city is located here, so you can basically release a early warning system and try to shut down automatically the important facilities. For example, underground metros and nuclear power station, and then the electrical power station and gas things and all can be closed. Automatic shutdown system can be operated, so that the disaster due to breakage of this can be minimized. Okay, that is how now the early warning system, early warning earthquake setup is planned in the country. So hopefully which will happen in the soon in the near future. So we have seen so how the India basically started its seismic network. So we have seen that before Shillong earthquake there is no seismic instrument, which was basically 1897. Before that there is no seismic instrumentation, only people have studied Kachakor earthquake in 1869 I think. So that time they studied that earthquake, where the Oldham was prepared a classical report. Then after Shillong earthquake, the earthquake instrumentation has been start installing. So until 1960 we do not have much seismic station. So until 2000, okay, we have very less number of station, and then many of them are vertical component kind of things. After 2001, okay, this has been considerably improved. Now the IMD put lot of effort basically to record this data, process this data systematically and give to researcher to get a proper output out of this. So which we will basically used basically to develop several things in the earthquake prediction related parameters, understanding and estimating and try to get the data. So hopefully in the near future we will also install the earthquake early warning network. So where people can know that earthquakes are occurring, they can try to shut down whatever possible in the in between the time period of P and S wave arrival. So that is a well help. So now the things are changing in the country where the time history data is made available to the researcher by a proper channel, which has been started very early. When I was doing my PhD, this was a big challenge, but now my students are able to get good amount of data. So this will also further improve in the future where we can get lot of regional level prediction models, okay, wave propagation theory understanding, getting the wave propagation prediction properly. As I told you that intensity shake map or intensity maps are not good at this level in the country. We are using some intensity map which is not appropriate kind of things, but still that is a as of now knowledge and status, so which will be improved in the future. So now so we have seen the wave propagation, how the waves getting recorded like P wave, S wave, which is seismometer will record, where the shadow zone, okay, so which are the waves we can expect. So then how these waves are we are measuring seismometer, what type of seismometer, what are the its capacity, and then in the country what are the seismic station development we have seen. So the next class we are going to talk about if you have the recorded seismic station with data from particular station with you, how you can estimate or quantify a earthquake, how to scale or how to quantify a earthquake we are going to see in the next classes. So with this I close this class. Thank you for watching this video. So if you have any doubts, so please get back to us weekly session in the TAs with TA as well as with me, and also write to me, okay, so that we will try to clarify as much as possible, try to make you understand what is this subject, will help you. So thank you.